Stop, fuckers. So the question of today is, can you write every integer as a sum of integer powers of 2? Meaning that, for example, you can write like, okay, 7, that's 1 plus 2 plus 4. Yes, that is the question. Or basically it's just binary. Can you translate any number into binary code? And of course that kind of makes sense because it's just a number way of denoting numbers. But yeah, we're going to prove it anyway. So what does this mean mathematically? So n is equal to, we're supposed to prove that we can always write any integer n, positive integer n, as a sum of integer powers of 2, where the powers are all different, of course, and yeah, different and greater than or equal to 2. So how do we do this? Okay, for this we shall use a so-called strong induction proof. So contrary to regular induction, a strong induction is, well, it's basically the same theory. It's derived from the same axiom, but it's just it's a larger, more general case, you could say. So instead of just proving that, okay, when n is equal to k, we assume that n is equal to k holds, then we prove that n is equal to k plus 1 holds. We instead, we're not really proving the statement in itself, but our induction assumption or our induction statement is that rather that this thing here holds for all cases up to k. And you could kind of easily see that that's actually the same thing. So what do we have here? Okay, so we just start with the most simple case, with just like 1 and 2. Those are just obvious. It's 1 and 2. So therefore, we make the induction assumption that for when all n's up to and including k hold. So this is our induction assumption that all n's up to k hold. So in this case, it would be like 1 and 2. Both of them hold. So therefore, we assume that, and now we're supposed to prove that it also holds when n is equal to k plus 1. So here, obviously, just the first case, if k plus 1 is a integer power of 2, then that's just done. We don't even have to write that down. Or yeah, you should write it down if you're actually writing it on a test or a competition or whatever the fuck, but I'm not going to write it down. So now let's get to the actual proof. Okay, so it's not a power of 2, but then we look at, okay, what is the largest power of 2 that we can create that is still less than k plus 1. So we say find a, we can call it a, such that 2 to the power of a is less than k plus 1, which is then less than 2 to the power of a plus 1. So in this case, if our k plus 1 was like 7 or something, then our a, or 2 to the a would obviously be 4, and then that would be 8. So therefore our a would be 2. So we find that a, and then we look at, we can call it maybe k1. We look at the number k plus 1 minus 2 to the power of a. That is obviously an integer and it is larger than 0. So therefore we know that k1 is a, I can just write a sum. Since we know that, okay, k1 is strictly less than k plus 1, then we know that we can write that as a sum of, integer powers of 2. So therefore we can rewrite this as, okay, our k plus k1, maybe we call that this sum, we can denote it with like p's or something, I don't fucking know. So we know that k1 we can write as, with integer powers, of course, p1 plus p2 plus all the way up to, I don't know, I'm running out of letters, p, maybe you need the pr, maybe you need r1, and then plus 2 to the power of a is then equal to k plus 1. So yes, exactly. So unless a is equal to some pr, then here we have a sum of integer powers of 2, with different integer powers of 2, that is. So in that case, if a is not equal to some p1 or p2 or anything like that, then we're just done, because then here we have obviously we have a sum, But if there exists, so now let's look at, is it possible that there are any ones in common? So from this thing here, we knew that our k1 was equal to this k plus 1 minus 2 to the power of a, and we also knew that k plus 1 was larger than 2 to the power of a and less than 2 to the power of a plus 1. So here we can just add that this is, well, okay, so we switch k plus 1 for these two things here. So I'm just going to erase that. So, okay, we know that it's k plus 1 is larger than 2 to the power of a. So we have 2 to the power of a minus 2 to the power of a. So that is just 0. Yes, good. We know that it's larger than 0. And then what is it less than? It is less than 8 to the power of 2 to the power of a plus 1 minus 2 to the power of a. And then if you do that, then you can extract like a 2 from it. And this is just 2 to the power of a. So therefore, if k plus 1 is equal to this sum here, and if that were to have a 2 to the power of a, then k1 would be greater than itself, basically. So that, of course, is a contradiction, and therefore we know that all of these powers are unique, and therefore we have written k plus 1 with a unique sum of integer powers of 2. So yes, thank you so much for watching. Check out the link in the description, and hope you enjoyed the video. Have a good one. Bye bye.